Good evening, everyone. This is Namrata from Mumbai, and I'm excited to speak to you for the next 1 hour. It's an odd situation where all of you can hear me, see me, but I can see nobody. So uh, let's go through the 1 hour. If there are any questions, please feel free to send them out to us. We'll be receiving them here, but we'll be answering them at the end of the session. I'm open to any languages as well, so please feel free to send questions in any language. Hindi, Marathi, English is what I know. This presentation is hosted by Tiscon eDiscovery. It's the 17th in the series. And what we are going to cover today is ventilation ideas, which includes door and windows for standard individual homes. What my intent is for the next 40 minutes of this session is to go through both the ideal and the standard aspects of ventilation design, to cover the technical specifications, which are the basics which anyone needs to know, and then move on to some innovative ideas, to some thinking out of the box, and also keep the forum open to talk about ideas and thoughts that are not talked about in the general books. So rest assured, my attempt is going to be to make this as interesting and as interactive as possible. To begin with, what we're going to do is go through ventilation, its definition, its methods, factors, design parameters, and finally, like I said, some ideas that are different from what's talked about in the book. What does ventilation ideally mean? I'm sure most of you know the textbook explanation of ventilation, but in a layman term, basically ventilation means an exchange between two spaces, exchange of air, odor, heat, vision, and indoor environment. Ventilation, in an essence, is an attempt where we are trying to improvise on air quality within the space. We are always trying to get natural sunlight within the space and ensure whatever the human beings smell is at the optimum levels. What you're seeing right now on the screen is what I call ventilation redefined. This is not something that you're going to find in the books, in a textbook version of definition of ventilation. This is what has been defined as ventilation today. This is what you will see in the industry, what people are doing as ventilation. Of course, like I said, fresh air. When we talk about fresh air, it's the air that we are breathing. It's the air that we are within the space. We are feeling through temperature, which is through the exchange of heat with our bodies. It's also the air which is coming from outside and going from this room inside to the outside space. It's very important this air is constantly kept fresh at the optimum levels for our comfort. The second point talks about diluting inside air for odor control. So like I mentioned, all of our senses are active when we are in any space. So one of the senses being what we smell. The optimum ventilation will ensure what we smell is comfortable, is at optimum levels, and does not have any contaminants that affect the human sense of smell. Third point talks about to remove contaminants. Now this is a very important point, although in the textbook definition of ventilation, this is something that's largely ignored, especially in a country like India. Contaminants is almost never talked about. If you sit on a table talking about a project or a design, people almost tend to ignore what contaminants can do, what are the sources of contaminants, where do they come from, how do they come into a space, and how can you control that. So to understand what are the sources of contaminants, how can they be filtered and removed from the space, is very important, and that's a part of the strategy of ventilation. And of course, through doors and windows, it becomes important to control the contaminants entering into the space. Fourth point being thermal control for comfort. Now this, I guess, is the large chunk of focus for any design. Usually people talk a lot about heat and cool. How hot is the space, how cool is the space. And I think most of the projects today focus on indoor air conditioning, central air conditioning spaces, and there is this constant talk that you'll find about why can't buildings be naturally ventilated. While the focus on that discussion from an energy perspective is there, it's also important that people should stop by default assuming that thermal control has to be done through mechanically ventilated spaces, through air conditioning within the room. Thermal comfort can be done in a lot of ways, and yes, it's the most important factor for ventilation design to make a human being comfortable within the space. But what we don't realize is that it is given a lot of importance compared to the other factors that you see on the screen. When you talk about fresh air, when you talk about vision, when you talk about odor control, these are very important part of experience, and we often tend to neglect them. We don't realize that these factors are ignored, but when you bring them together in the design, you realize they play a huge role. So yes, thermal comfort is obviously a very important part of ventilation design, but it needs to be balanced along with the other factors. Finally, vision. Vision is very direct. Every space, if connected to natural outdoors, brings in natural sunlight, and it's very important that is there, because once the human eye has contact to the natural light, it adds a sense of belonging. This is something that most engineers and architects fail or miss when they design, because natural sunlight and natural vision is often talked about from the angle of energy saving, or not having to turn on the light. But no one is realizing the human psyche that it is involved with it. The moment our eye sees a natural environment, a natural surrounding, it has a very different impact on our physiological being. It has a very different impact on how our minds work. It automatically makes the human being feel at home. It makes the human being feel comfortable. So it plays a huge role in making a person's indoor environment comfortable. And that's why it should be given a larger importance than what we do today. So yes, fresh air, diluting inside air to remove contaminants, thermal comfort, and vision. These are the 5 aspects that you'll find in every textbook for ventilation and any subjects related to ventilation. What I want to talk today about is the other 3 factors that you see on the screen, which are not directly mentioned ever in ventilation design, but they have started taking precedence in the recent times, especially in the last 5 years. The first one being optimum heat loads and energy consumption. Now, we've all talked about fresh air, we've all talked about thermal comfort. But how do we know? How do we know the heat loads within the building and energy consumption are optimum to ensure the fresh air is to the level that it should be, and the thermal comfort should be is to the level that it should be? There are a lot of ways with the newest techniques of getting buildings certified, designing green buildings, having certification methods in LEED and IGBC. It's become a lot more easier for us to measure these aspects. I will be talking about green buildings, LEED and IGBC in the next segment in a brief, short span of time. But here, what I want to make a point is that optimum heat loads and energy consumption is something that is not included as a by default factor for ventilation, but it becomes a very important factor. Heat loads are added in the building through human bodies that come and go from the space. They're added through equipments that will be within your space, like right from a printer to a mobile phone, to cameras, to even using mechanical doors, any mechanical systems in and around in your building. These heat loads, although you don't realize, are getting exchanged between spaces. These are different from your air conditioning systems. These are different from your plumbing systems or any other systems that are adding to the heat load. And they play a very important role in your comfort level within. Coming to energy consumption. Within one room, since the subject is about door and windows for individual homes, I thought it was important to discuss these 3 factors. When you're within one room, besides the human bodies, there is cell phones, laptops, objects that include furniture, that include lighting, that include, if you have kids at home, there's toys. So there are various objects within the space which we don't realize have a certain by default energy consumption that they do with the universe. There is an exchange of heat, exchange of mass that's happening along with the universe, and they add to a certain heat load factor in your space. And which is why it's important to understand how location of door and windows can help balance these heat loads, how optimum heat loads should be retained within a space to ensure the ventilation is at an optimum level. Coming to the next point, which is indoor environmental quality. Again, this is also one of the sub-factor that has now become very important to us because of the subject of green building in certified buildings. Indoor environmental quality is not just a term. It's defined in detail technically to be able to measure every little substrate of contaminant in your space. It includes, how high or low is your lighting. It includes how many minute or substrata of particles coming from a cleaning agent or from a spray or from a cooking activity that is happening in your house, and how those particles have added to your indoor air. We are now seeing that there is increasing cases of allergy related problems that people have in a country like India, which probably a decade ago was not very normal. There are cases where people talk about having a pollutant allergy. Where do you think this is coming from? I mean, when you're inside your homes, if you have your doors and windows closed, how is it that pollutants are still affecting the residents? It is because of these indoor environmental contaminants that are coming through the activities within the space, and that's why making sure the ventilation is taking care of exchanging these contaminants is very important. And finally, insulation. Of course, insulation is a very direct subject, but it is something that is never talked about when it comes to ventilation, and that is why a lot of designers and engineers miss the point to include it in their design. Insulation plays a huge role in ventilation, insulating your walls, insulating your ceilings, basic insulation for noise within two spaces, insulation for smaller openings under the doors, between two windows. These play a large role in your thermal comfort within the space. So I think insulation is a very important factor that engineers and architects should start including in their ventilation strategy. So to sum it again, although traditionally ventilation is defined through fresh air, diluting indoor air, removing contaminants, thermal comfort, and vision, the three new factors that are becoming increasingly important include heat load and energy consumption, indoor environmental quality, and finally insulation. So now that we understand what ventilation is, which is in a layman term, like I said, an exchange of air within two spaces, let's understand what are the methods of ventilation. I'm going to cover a very direct technical understanding of this subject. Then we are going to come to some creative ideas as well. So, we have both the bases covered, but if there are questions, please feel free to send them specific to a certain project or specific to a certain approach. So ventilation is delivered in two ways, natural or mechanical. I would not say that in the current times mechanical is the most common way. No, in fact, people are finding, you will find people and clients coming to you demanding natural ventilation more and more these days, because there is more and more awareness for energy consumption. There is more and more awareness to make habitable spaces, to make spaces that are sensitive to human requirement. And like I mentioned earlier, there is a huge role that our psyche plays in terms of our comfort within the space. And when it comes to our psyche, the connection to the outdoors, the connection to the natural environment becomes very important. Coming back to the subject of natural ventilation, it contributes in an increased way to your airflow within the space and helps in reducing loads on mechanical ventilation. And that's the reason people prefer natural ventilation. It saves energy, it saves cost, and it gives you that connection to the natural outdoors. What are the ways in which natural ventilation is done? Obviously through the two things which is the crux of our talk today, which is doors and windows. It's done through the openings within the buildings. It's done through optimizing the location of these openings so there is exchange of air in the right direction within the space. It is designed in a way where from one space of a humid or a hot space, the air is taken out to another space to create room for a cooler environment. We'll look at some diagrams in the few slides upcoming after this. Coming to the mechanical ventilation, which is the second type of ventilation, like the word mentions, it's very direct. It uses mechanical systems to help you achieve ventilation within the space. Whether you do natural ventilation or mechanical ventilation, what are the two main factors that you do in ventilation? It's simple. One is supply, second is exhaust. When you say supply, you mean you're supplying the space with what it needs, the fresh air, the fresh non-contaminated particles that it needs. And when you mean exhaust, you are trying to basically remove the contaminants, you're trying to remove the hot air, you're trying to remove the odor, and you're trying to get a better thermal comfort within the space. So supply and exhaust, these are the two terms you need to always remember when you're talking about ventilation. Whether you're doing it through natural mode or mechanical mode does not matter. You need to make sure you're giving enough supply of fresh air to your space, and you're making sure there is a system through which there is an exhaust happening for contaminated air. Coming to the unit to measure ventilation, in technical terms, it's measured in cubic meters per hour per square meter of space. Cubic meters, which is the volume of air, per hour, which means in one particular hour, how much volume of air am I going to circulate. This is measured against a square meter of space. So essentially, we are taking the space into consideration, we are taking time into consideration, and we are taking volume of air into consideration, which covers ventilation. How does this impact design or engineers? So let's say you have a room of 15 square meters, that's 150 square feet approximately. It is important for you to understand how much cubic meters of air you need to exchange in a particular hour per square meter of that room, multiplying it by 15 to give you the actual total volume. If you're doing this by natural means, you're going to understand how many openings you have, the surface area of the openings, and how much air it's going to give you, and accordingly design your openings. If you're going with the mechanical method, you're going to then calculate how much tonnage you are going to need for your mechanical ventilation to fulfill this requirement. Coming to the factors that affect ventilation. So we've understood what ventilation is. I'm just going to do a quick recap. We've understood ventilation is exchange of air with the 5 main factors and 3 factors that I've just explained to you, which are becoming increasingly important now. What are the 2 main things or strategies you need to remember to do ventilation? One is supply, second is exhaust. Once we've understood this, what are the factors that impact ventilation? What are the factors that are going to impact your efforts of ventilation when you're trying to do the supply and exhaust? First one being velocity of the wind. Of course, if the wind is higher than expected by you, that's going to be impacting your natural ventilation strategy. If it's lower than expected by you, then you're going to have to strategize your openings in order to increase its velocity. So of course, velocity of wind becomes important. Direction of wind, which direction you're getting it from, because it's going to directly impact your door and window locations. Disposition of openings. By disposition, we mean you might know that you have to have it in a certain direction, but in that direction, how are you going to place it? How high, how low, how wide, and at what angle? So those are the things that get covered in disposition. And convection effects arising due to pressure difference. So pressure is again another factor, just like insulation, which is highly ignored when it comes to ventilation design. Convection effects, as we're all architects and engineers here, so we all understand the meaning of convection. It's coming from a difference of low pressure and high pressure between 2 spaces. There is a convection heat wave that gets created, which impacts our thermal comfort, and which is why understanding which is the lower pressure area, which is the high pressure area, which is the windward direction, which is the leeward direction, becomes very important in your ventilation design. So I'm going to quickly summarize factors again: velocity, direction, disposition, which is where, how, and at what angle, and convection. These are the 4 factors that affect your ventilation. So finally, coming to the sizes. We've gone through what ventilation means. We've gone through how it's done. We've gone through what are the factors that impact ventilation. And we've gone through the 7 main key factors that come under the umbrella of ventilation and what define ventilation. Having understood that, we now are coming to the sizes of doors and windows. Now, so doors and windows are basically a subset. Each of them are subsets of a large term called openings. Openings could be either an entry to the room or a window which is going to get you light and ventilation through the space. Ideal sizes for doors and windows are as per what you see in the screen. These are obviously our textbook sizes, which people follow across the board globally, but these also become case specific, region wise, based on climatic zones. They need to be tweaked a bit. So, at the end of the session, if there are specific questions on sizes, I'm happy to look at them, because sizes get impacted basis your region, your climate in that region, and also the typology. Are you designing this, single home? Are you designing a commercial space? Are you designing, a museum? Based on that, a lot of things impact the door and window sizes. So coming to the doors, ideally 1.2 meters to 1.5 meters for main entries. Larger hallways should be sufficient. The reason I am mentioning 1.2 to 1.5 meters is also because, as architects and engineers, we need to start being sensitive to the requirement of handicap as well. And this just does not include, only the people using wheelchairs, but a larger segment of people who need special care. That includes people who have hearing disability. That includes people who have vision disability. That includes people who have speech disability. So I think our doors, hallways, main entryways to your homes, to your buildings, need to start catering to these requirements. Usually 1.5 meters or a little higher is preferred in that case. If you're in the indoor space, which is like going from one room to another, like going from a kitchen to a living room, or going within the room to a bathroom, and you need to give a small passageway, usually a 900 passageway is enough. You can go a little lower if you like, but it's not recommended. A global standard would be at 850 to 900 People do go lower in certain specific cases, although not recommended again. Coming to windows, I'm going to start with a normal apartment like we all have in India. We have, normal 1 BHK, 2 BHK, 3 BHK apartment, which usually has a living room, a kitchen, a few bathrooms, and your bedrooms. As per a norm, it's good to have all your living room windows open up into an open space. So it's either opening up into a courtyard, a garden, or any kind of open green space. Any of the bedroom windows, if not directly into the open space, should at least, if not more, at least 3 meters of open space in front of it. This ensures there is room for ventilation design to happen successfully. Having said that, window sizes range from 1.2 meter to 1.5 meter in width and height for rooms of up to 15 to 20 square meters. That's up to 250 square feet approximately. And 1.5 meter to 2.4 meter range width and height for rooms which are larger than 250 square feet. For a living room or a bigger room, you can even go up to 4 feet by 6 feet. Bedroom, you can go for 4 feet by 4 feet. Kitchen, you can choose a 3 foot by 3 foot window. You can also choose a smaller window and multiply it by 2 or 3 depending on your kitchen design. Kitchen ventilation is very critical because you have a lot of heat and smell developing there. And if the ventilation design is not rightly designed, it can lead to contamination across the house. One of the things that current kitchens or today's kitchens also propose is a chimney. which is a good way. It's a mechanical approach. It tends to collect all the contaminants, the heat from the stove, and take it out directly. It's highly recommended for households which have a high proportion of non-vegetarian food being cooked because of the oil, the smell that needs to be ventilated. But in my opinion, every kitchen should be given at least 2 openings, which is what we lack in India in a lot of cases. People normally just give one window with an exhaust at the top. What we don't realize is what we are doing in that is we are giving only one face of the building to open up into the kitchen. We need to have that another phase where the air can exchange and the odor can exchange, and that's the optimum ventilation. So if you ever have an opportunity and that is possible, always look at 2 openings on 2 different walls for kitchens. Bath ventilators are typically 2 feet to 3 feet. You can give them with louvers, without louvers, and one wall usually suffices for a bath because here, the activity is for a very limited period of time. Usually, it's in the mornings for a few minutes and in the evenings for a few minutes. So, bath ventilators, you can afford to have on one wall with a smaller size. Okay, so now we're going to cover a couple of typology and specifications. I have purposefully chosen to not go into technical drawings in this area. There will be plenty of technical drawings you'll find across the board, online, in textbooks, everywhere. One of the other reasons I chose not to have drawings is because today design has become a very wide subject, and even for something as simple as door, there are various, I don't even have a number, there are hundreds, thousands of ways in which a door can be designed. And so to limit it with a drawing and saying this is how your frame, your lintel, and your door frame should be placed would not be fair. And that's why I'm just going to go through a couple of elements of a door and window design, and we'll then come to how to use them. We have following elements within the door and window design: frame, lintel, panels, sill, railing, and finally the material for each of them. Starting with the frame is what will define your opening. It will be what will define the size, the location, and how it looks. It is typically the box, if not a box or any other shape in which your opening is placed. Lintel is what goes above your opening. Typically for doors, lintels act as a structural support. So imagine you have a large wall and you're suddenly puncturing it. You're actually disturbing its load distribution. So in a layman terms, and I'm sure all of the engineers and architects listening to this understand this factor, because this is what what we do in school. But it's important to cover the subject, because it takes care of the structural distribution. The lintel ensures the structural distribution is not disturbed and it is transferring in the right way all the way to the ground. Coming to panels, panels are what you hold, what you interact with as a human being. When you open your door with a handle, when you shut the door by pushing it without a handle, if you're seeing through the door or a window, which it could be glass, when you talk about having whether the opening is giving you enough insulation to make sure your cooling within the space is staying within. All of these are basically subjects that are related to the panels, how the panels are placed and how they are designed. Sill, it's the portion of the wall which for the window which goes at the bottom. It's essentially, in a layman term, the small part of the wall that comes under your window and completes your frame. Railing. Railing is not directly a part of door and window, but it's important to talk about it because in this generation where buildings are typically or usually more than 4 to 5 floors, all windows on the exterior of your facade, so whether it's a bedroom, it's a living room, doesn't matter, directly open out. And whether you're on a first floor or fifth floor, doesn't matter. Railing becomes very important. Railing is a safeguard factor, and it has to be given, if you do not, if you're directly basically opening outside. And coming to the material. Now, material, essentially people talk about materials in terms of aesthetics, in terms of what you touch, feel, and how you like it. But, it's very important to choose the right material because it plays a big role in ventilation. Having a wooden door can not only be a visual barrier, it can also be an insulation. It will be a huge and a great insulation for the space. So let's say you are in a mechanically ventilated space. Your wooden door is going to be stronger and going to contribute more in controlling your heat exchange between two rooms, or cooling exchange between two rooms, compared to a thin glass door. Um, if you're going to have, from a vision point of view, for example, if you have a large door, you can choose to have one panel or more panels of glass within the wooden door or within the metal door, so that adds to your vision. So choosing the right material to contribute to your ventilation design becomes very important. So again, just to quickly summarize: frame, lintel, panels, sill, railing, and material. These are the factors you need to remember when you are designing the openings for the buildings. Coming finally to the design parameters for ventilation. So we've understood what ventilation is, what are the types of ventilation, what are the factors that impact the ventilation, what are the standard sizes for doors and windows of a typical house, and what are the different typology and specifications for the openings. Coming to design parameters, as an architect or an engineer, there are a couple of things which we should always look at or list down before we start deciding how our openings have to be. That include, what is the orientation of your openings? So one of the things we learn as designers is that to do a study to understand the sun path diagram, to understand the wind direction in your location, whether you're building a large building or you're working on a small apartment. Understanding where your light is coming from and in which direction your wind is moving is very important. And once you've understood that, you will have to work on how to orient your openings. So just knowing that I need to place my opening on northeast is not enough. Am I placing it at 90 degrees, at 30 degrees, or at 60 degrees? That becomes important, and that gets dictated by both your sun and your wind direction. Next point is inlet and outlet opening should be in windward and leadward direction, which is a very direct point. I mentioned it in a previous segment as well. Understanding to place your doors and windows directly facing your inward and outward direction of the wind, which we call as windward and leeward direction, is very important because it completely supports the wind direction and enhances it. For total area of opening, as a thumb rule, 20 to 30% of your floor area is good. So let's say your room is about 100 square feet. You're looking at 20 to 30 square feet of openings within the room. You are in a good range, and then making sure the direction, the orientation is correct will help you achieve the right ventilation. Inlet length should be at least 30 to 50% of opening with wind perpendicular to the opening. So we've talked about the location, we've talked about the percentage. Now we're coming to the length. So within your percentage, so like I said, when you're looking at 20 to 30 square feet, within that percentage of area, you need to make sure 30 to 50% is given to the length. This is in order to ensure that length is able to capture the required wind. Ideally, living room should directly open to an open space outside, which I've already mentioned. Two windows on single wall preferred to a single one on one wall. So the reason I mentioned this point is I often see a lot of builders design where you'll see a typical living room which is long in length. You're going to have a typical seating area on one side and you're going to have a dining area on the other. Typically there is a passage in between or on the side going to your bedrooms on one side and going to the kitchen. This is a very standard format of residential design you'll find across India. Now, one of the drawbacks in this design is you'll see in a living room, in a case of a living room, I'm going to start with living room. You'll see one of the face is usually on the lobby side because that's where you're entering the house, and the other face is on the exterior wall. They give you one opening on the living room side. It's an absolute disaster for ventilation. You have this long space, almost up to 300 square feet, 250, 300, 400 in some cases, and there's only one opening. Yes, they say, oh, we've given you a full length opening, but then the opening is worthless because it's not contributing to my ventilation. There is a way for the wind to come in, but there is no way for the wind to go out. It's getting trapped within the house. Or vice versa, when there is a heat wave created within the house, it does not have the way to go out and bring in fresh air. So what's essentially happening is that opening is not adding to your ventilation, it's actually ruining it. In such cases, if you are facing a scenario where you don't have an extra wall to give an opening, like I mentioned during the kitchen discussion, try to have two openings. When you don't have that, it's preferred to have two smaller openings rather than taking the bigger opening. So you should take two smaller openings, balance your length, balance your area, but give two openings. What this does is, essentially there is a smaller proportion of wall that's left between the two, and that creates two separate openings, and that helps the wind create a flow where it can come in and go out, so that the supply and exhaust is enhanced. Although it's not the optimum situation, again, it's always best to have at least two openings for any room on different walls. That's the thumb rule. Always remember that. If that's not possible, you can look at one wall, but always prefer to have two openings. Any designer, any architect might refute this. They might say, no, why should we lose the opportunity to have that large window? But we do not realize the impact on ventilation in that case. Horizontal sashes at 45 degrees are preferred. Now, horizontal, vertical fins, sachets, these are louvers, these are strategies used, when you're trying to avoid mechanical ventilation, you're trying to control glare, you're trying to control the heat. So, this approach basically takes into consideration what is the angle of the sun, what is the angle of the direct light, how the glare is coming in at what times, and based on that, the angle of horizontal and vertical sashes are designed to help you with optimum ventilation. And finally, the daylighting comfort to be considered. So again, coming back to that point of living room. So I mentioned to you what is the problem with our living room design. In the same case, imagine having opening only on one side. You are essentially bringing in natural light only from one side for the entire length of the room. So that natural light is actually not covering the entire length when you have that much area available to be able to do it. And in this case, two openings is not going to help because this has nothing to do with the wind movement. We are talking about the lighting control. So again, as far as possible, always try to give two openings within one space on different walls. Okay, having understood that, let's come to a few strategies. This segment is purely for those who are interested in understanding planning and design and how to do the ventilation design. You'll see a couple of sketches on the screen. On the left, you'll see a couple of plans, and on the right, what you look at is section. I'm going to start with the sections first. On the topmost corner, you're seeing an opening on the left and on the right where the sizes are different. So if you see, the opening on the left is shorter than the one on the right. What it's doing is it's bringing in air with a higher pressure because the opening is smaller. And because the opening on the right is bigger, it releases the air due to the pressure difference. This is a good strategy for ventilation. It helps wind movement, it brings in fresh air, and immediately, due to the bigger opening on the right, it gushes the air out and helps with the air movement. What you see on the left in the second row is what they're trying to talk about here is air from the top and bottom. Now, in this case, there is no opening on the right. So what they've done is instead of dividing your opening in the vertical, they've placed opening one below the other. This is again a wonderful strategy because you're always going to have hot air on the top, cold air at the bottom, which is going to ensure there is continuous ventilation happening. The one on the right and at the bottom are what typically we'll find people do, builders approach, and they don't give you a great sense of ventilation because there is no care or size difference in the window, and that's why it's a straight air movement. It doesn't enhance wind velocity. It doesn't take care of wind velocity, and so yeah, you do have air movement, but they are not the most optimum scenarios. Coming to the plan, I'm not going to go through each one of these. Please feel free to go through them. If you want to speak about something specific, you can do that in your questions. The one which I want to talk about is the third one from the top. So the third one which is under the poor section. If you see, there is two openings on the same wall and they're in the same direction. On either sides, there are two notches. Now, what the individual must have tried to do is give two openings on one wall, like the strategy I talked about before this. But if you see, he's failed at achieving ventilation because he's given notches on either sides, and the air, instead of circulating with a certain pressure, is getting blocked. He's not achieving the velocity he wants, and so the ventilation is poor. But against that, if you do the same scenario, and what you see on its left, which is the second image, instead of having notches on the side, it's in the center. So what he's essentially done is, when the air is trying to move out, it's open. So it's gushing out due to the pressure difference. And same with the first image. If you go to the leftmost image, which is the first image, it's even better because instead of having one notch, he's added two. So there is a pressure, there is a low pressure created when the wind is coming in, and there is a high pressure created when the wind is going out. And this enhances ventilation. The only reason to include this sketch was to understand that while you look at the size and location of the ventilation, it's also important to understand the inward and the outward strategy of ventilation, which is clear from the first three sketches, which are under best, good, and poor. Once you have identified the location and the size, how is the opening designed? How is the wind coming in that little area, and how it is going out to create the right pressure, low pressure and high pressure, to enhance ventilation is very important. This slide is made only to discuss that point of single opening and two openings that I was explaining in the previous segment. It's very clear from the sketches on the left hand side. You see a single opening, how the wind movement is, versus two openings of almost the same size, versus three openings in which you have one opening on the left and two openings on the right. So you see there are two openings on the right, which creates a pressure difference again and enhances ventilation. So again, the strategy is to create pressure difference, which enhances wind movement, which in turn gives you a better quality of ventilation. Again, a couple of sketches for those of you who are more interested in studying the subject on how the window openings and door openings should be placed. Cross ventilation is the best strategy, very simple and direct, having openings on either sides. Like I said, keep one bigger, one smaller. That enhances pressure difference and helps you in ventilation. What you see in the on the right is a case where you have a ground plus one or a bungalow kind of a scheme. One of the strategies typically architects use is have an opening on either sides. One is lower, the other is higher. Simple funda, you have a hot air on the top, cooler on the bottom. It creates a pressure difference and you're able to have a good quality of ventilation. What you see in front of you is a very good sketch to explain to you what I explained to you in the start, which is ventilation redefined. Please don't think of only the 5 factors. Extend your ventilation thought and look at how this sketch is explaining beautifully. You see sunlight is coming from the top, not only light but wind. Light and wind are both taken into consideration in designing each opening, which in turn contribute to your thermal comfort, to your contaminants exchange, and enhance ventilation. I'm going to go through a couple of factors quickly. Where you see one is marked, it talks about night sky radiant cooling. The roof design is taking into consideration a material that can reflect the heat back. So that helps in making sure the heat load absorbed from the atmosphere is lower, and that helps in reducing the heating load of the building, which in turn means that your mechanical ventilation cooling requirement is lower and you're saving energy. I would like to talk about point number 6, which is light shells. Point number 6, light shells helps you. So when I talk about the length of the room and where your light is not coming in all the way, one of the ways to achieve it is by helping it get reflected on certain surfaces and go all the way in. So light is a very good element, and it is very good at reflecting itself and bump off the surfaces. So once you add a horizontal surface at the right location, it will bump off it and keep traveling further and further. So yes, when you have challenges of length and challenges of not being able to give more openings, you should look at strategies where and how can you make the wind and the light travel that distance, because they are both fantastic travelers. Light and wind can travel beyond what we can perceive. So you just have to figure out a way for them to travel that distance. And the last point I want to talk about is point number 10, which is basically fully lit interiors. So you know the height, the or location of the openings on either walls, it's all thought over in a way such that every space within the room is having daylight. Other than that, you feel free to go through all of the other points and share questions if any you have. I'm coming back to this slide because this is, in my opinion, the most important factor to understand ventilation, to make sure all of these 8 points are covered and thought of when you design a space. I'm going to quickly, in 2 minutes, run through a couple of ideas and then come to a case study, which I think is very innovative when it comes to ventilation design. What you see here is just a couple of ideas on how openings are dealt with. The reason I'm using the word openings and not door and windows, you'll find me using the words doors and windows very minimal in this entire talk, is because it limits us. It limits thinking of a door as a door limits us. Thinking of a window as a window limits us. We should understand how openings can be designed beautifully and still take care of ventilation. What you see in front of you is an opening where it's essentially a door, but also doing the function of dividing the space when it's open. It also helps in controlling how much you open your space. You can choose to open only 20 degrees or all the way up to 180 degrees, depending on how much vision of the interior space you want to give to the outside person. So if you have a mailman, you can choose to open only 20%, do what you have to, and then shut it, or you can keep it all the way open. And let's say you have a gathering, a party, and you can keep it 180-degree open. It divides the space into two. One can be an entry, other can be an exit. So it's one of the beautiful ways of dealing with an opening. There is a glass panel on the side. They've chosen to keep it not completely transparent. You could have kept it completely transparent in case you were trying to have full vision through the space. This is another way where you see larger openings in windows with a door which has 4 panels. So it not only divides the space, it's also bringing in a lot of natural light, and at the same time giving you an opportunity to divide your opening itself in 4 different sizes. Another similar example. The only reason I've included this image is this is a new way of thinking of openings, which is why I mentioned I have purposefully chosen not to have door and window drawings on this segment, is because if you look at this window, you will not see the typical frames and the typical panel design and the typical hinges. This is a very minimalistic design, and that is how our opening designs have evolved today. Now, another example of how openings can be dealt with differently in your sizes, division, and as well as materials. Okay, finally coming to one of the case studies, which in my opinion, is remarkable beyond its beyond its time. It was this building was built in the 19th century, and it crosses innovation even today. I don't think any building today is able to achieve ventilation design in a way that this building does. This building is designed by Renzo Piano, a very famous architect. He built a museum in which is called Zentrum Paul Klee, in very close to Switzerland. This museum, if you see in the image, is 3 curves placed next to each other. Now the structure itself is an opening. The entire structure is a series of openings placed next to each other. If you see the front wall, the entry itself is an opening with louvers, with sunshades. The roof is designed in such a way that at every part, the opaque versus transparent part of the roof is custom designed based on what sunlight is coming directly on that side and how much heat load is coming on the building. A couple of views. It's a beautiful building. It is completely naturally ventilated. They don't use any interior lighting for most part. 95% of the times they don't have to use any interior lighting except for the dark days of December in winter. They have very heavy winters. It tends to go all the way up to -15, and yet they are able to optimize the sunlight during the daytime to ensure the building stays warm. So it's a beautifully designed building. This is one of the interior shots. You can see there is not a single interior light which is turned on. Look at the height of the room, the length of the room, and yet they don't need any interior lighting. So that brings us to the end of our segment. In my opinion, today, green buildings, sustainable buildings, energy savings, intelligent buildings, these are the terms which we come across every day. It's important to understand these terms. It's important to understand how these terms impact our design. When it comes to ventilation, it's a very vast subject which is probably not given its due importance. We as engineers and architects should give it that much importance. And to do that, we should relook at ventilation, not with the 5 factors which the textbook gives us, but with the redefined version of ventilation. Take into consideration insulation, take into consideration optimum heat loads, and then design your buildings. I'd like to mention a couple of resources that you all can look at. National Building Code of India, the ASHRAE, which is the American Society of Heating, Refrigerating and Air Conditioning Engineers. All of us use it. Mainly the MEP team is always referring to these books. Indian Green Building Council's green building ventilation requirements. Now, Green Building Council has come up with its own certification, which for green buildings, which is called the IGBC AP. They certify green buildings. They have a specific book in which there is a segment on ventilation requirements. It's in depth, beautifully designed. If anyone has questions, you can always feel free to reach out to me. Otherwise, and finally, the Central Public Works Department of India's door window standards, which is going to help you with detailed sizes of each element, whether it's a frame or a panel or a handle or a hinge for a door and window. So yes, again, repeating the resources: National Building Code of India, ASHRAE, IGBC, and Central Public Works Department of India's door window standards. And over and about this, we can now open to questions. I will take a few questions depending on what the time permits. If anyone has more questions and would like to discuss any subject in depth, my coordinates are on the screen for you. You can reach out to me on email on namrasha@gmail.com or on my LinkedIn profile, and I'll be happy to assist. Thank you. Okay. Are they able to hear me? There is one comment saying not in sound. Okay. So there's one question from Mr. Vikram Kumar. He's asking, insulation is usually done using polymer compounds. Why has that not been picked up in pace in India, or is it not being readily used? So it's a very good question, Vikram. I don't know if you are actively pursuing green buildings or not. But if you are, if you read the books and the requirements of green building, polymer is covered in depth in 3 areas, which is MR, which is called materials and resources, IEQ, which is indoor environmental quality, and in the HVAC section. They specifically pick up on how much component of polymer can be used, whether it's for insulation or for any other purpose, how much quantity is optimum for the building, and what kind of polymer compounds can be used. So yes, it is used in India. To come to second question, why it's not picked up pace, there are a couple of reasons. One is the lack of know-how. Very few companies understand polymer compounds today. Very few companies are using it as their insulation method. Largely, a lot of companies have now started picking up on that technology and bringing it. Second reason is, so one is the know-how. Second is also our lack of dealing with internal contaminants. We are still dealing with the basics of understanding contaminants, pollutants, what polymer compounds are. I find a lot of clients who need education on something as basic as CFC compounds. Why your refrigeration, needs to be low on HCFC compounds. So that's another part. We do need to catch up on that, but I would not say it's not used. It's definitely used. it's slow in pace. We have another question from Chitrang Rana, who says, what are the main parameters to calculate the mechanical ventilation for toilet and battery room which has a acid plum in the area? So Chitrang, for the toilet, parameters have to clearly be again direction and location. Direction is, if you see the National Building Code of India, there are two ways toilets are approached. One is the building code says you should have your toilets ventilation directly facing to the outside wall, which is the main facade of the building. Now, in certain cases, due to the design of the building, that becomes a concern for the architect because they don't want to see that ventilation window on the facade. In that case, you have to approach mechanical ventilation, in which you typically create a duct. The mechanical team will take a shaft out through the duct, through and through the building, and ventilate it into the outdoors. Coming to a question on what do you do in the case where a battery room which has an acid flum in the area? To be honest, on the acid flum, I would really have to check that in our code book. But for the battery room, you'd have to look at how much heat is created with the battery use, A. B, you'd have to look at the direct sunlight parameter. So I don't know which battery you're referring to, but there are certain battery rooms which cannot take in direct sunlight. It becomes a natural requirement from the client saying we cannot have direct sunlight because it will impact our battery. In that case, you have to look at reducing openings and having mechanical ventilation through ducts again. People also tend to use smaller duct size if the size of the opening within the room is a concern. So they take smaller duct size, but multiple of them in the room. We have another question. This is from Anjan Nandi, who says, in kitchen, two walls are never available in a built form and materials are important. Architectural elements are more important in any space design with building type. So I completely agree with you, Anjan, which is why I mentioned, if possible, it would be nice to give two walls. If you're designing a larger space, these days, open kitchen formats, kitchen island design, these things are very much in trend. Which is where you have an opportunity to get two walls, maybe create openings or two openings in the same wall. So in that case, you can do it. When you can't, then of course you have to have the best possible solution, which would include probably introducing an exhaust fan or a mechanically ventilated chimney. Someone has requested to share the PPT. Please feel free to reach out to your organizers. They will do the needful. There is Smith who is asking, what is the degree like, 20, 30 or 50? The question is not very clear. I'm assuming his question is what it should be the angle of the window opening. In my experience, usually in an Indian climatic scenario in major cities like Mumbai, Hyderabad, Bangalore, Delhi, Kolkata, opening that is oriented anywhere between 20 to 35 degrees in the windward direction works just fine. So I hope that answers your question. There is a question, I think we have time for just one more question. There is a question from Mr. Biplab, who's asking, how is the size of ventilation depending on climatic condition like hot, dry, humid or cold zone? Very good question actually, Biplab. This comes back to my segment where I covered what materials can do for your openings. Basically, so let's say your opening size is 4 feet and it's all glazing in a hot and humid environment. What you're essentially doing is helping the hot and humid environment to bring in the heat into your space because you're using glazing and you're keeping the entire opening with full glazing. Vice versa, if you were to give that 4 feet opening with part glazing and part insulated material, which could be wood or any other material, maybe you introduce a horizontal shading or a louver, it is going to minimize or maybe reduce that heat load by almost 30-40%. So yeah, material does play a very important role, and the size of the ventilation. So if you have a 4 feet opening and you don't want to introduce a horizontal louver, you can go for a smaller opening, which will control your heat load. So that's how size is impacted in based on the climatic conditions. I hope that answers your question. If there is any more questions, please email them to me. Again, my email address is on the screen for you. Feel free to reach out to me anytime and I'll be happy to assist with them. Thank you so much for your time and I hope you enjoyed it. Okay, I hope